I welcome all the respected members and participants of the conference, International Conference of Environmental Remote Sensing and GIS. My name is Vijay Kumar Singh Rathore, and I have done this work with the help of Dr. Sudhir Kumar Singh and Dr. Anjani Kumar Singh. Myself and Dr. Anjani Kumar Singh belongs from the Department of Geography, KS Saket PG College, Ayodhya, Uttar Pradesh, India, while Dr. Sudhir Kumar Singh belongs to K Banerjee Center of Atmospheric and Ocean Studies, IITS Nehru Science Center, University of Allahabad, Prayagraj, Uttar Pradesh, India. My research topic is simulation of land use and land cover change and urban sprawl prediction in Lucknow Metropolitan area using Markov chain model. Introduction. Assessing land use land cover change is crucial for addressing environmental issues like unplanned development, loss of arable land, and habitat destruction. The escalating population in major metropolitan cities of the world causes urban area expansion, altering land use and land cover, and, and inducing urban sprawl. Predicting LULCC and urban sprawl aids in planning for future infrastructure, healthcare, education, and service needs essential for resource management. The land cover change model of DARSAT is an advanced framework merging GIS and remote sensing technologies to analyze and predict LULCC, employing intricate algorithms like multi-layer perceptron neural network and Markov chain, MLP, and a machine learning method discerns complex data relationships and identifying drivers like land use policies, economic dynamics, and population growth. The present study aims to simulate the LULCC in the study area and to know the future urban sprawl. The outcomes of the study will provide an insight for the planners to achieve the goals of sustainable development and for the management of natural resource effectively. Lucknow has witnessed a drastic change in LULC classes due to the increased population size, economic growth, execution of various development projects, expansion of human settlements, unregulated development, etc. during last decades. I have chosen study area for this study Master Plan Boundary 2031 of Lucknow Municipal Corporation. Lucknow is the capital city of Uttar Pradesh, which is the most populous state of India. Materials and methods. Data used. I have used Landsat 7, Landsat 5, and Landsat 10 of 2000, 2010, and 2020 respectively. Landsat 7 data belongs to Sensor Enhanced Thematic Mapper Plus, while the Landsat 5 data belongs to Thematic Mapper. Landsat 8 data belongs to OLITIRS. The resolution of all the data is 30 meters, and all the data sets were downloaded from USGS Earth Explorer. Image classification. All the three satellite images were corrected radiometrically and atmospherically for classification process. Image classification has been performed using the pixel-based maximum likelihood supervised classification techniques. In the present study, the images were classified into six LULC classes such as agricultural land, vegetative cover, built-up water body, scrub land, and sodic land. For accuracy assessment of the classified images, high resolution Google Earth image was used as reference data. Confusion matrix was prepared for each classified images using these sample points and reference data. Kappa coefficient was calculated from confusion matrix. The majority filter has been applied on the classified images for better predictive results. I have used 12 variables in this study. They are elevation, distance from road, distance from railway line, distance from water bodies, distance from forest, distance from built up 2010, distance from airport, distance from railway station, distance from bus stands, distance from metro stations, distance from hospitals, and population density. Except elevation. Euclidean distance were, were calculated for all the variables. And all the variables were transformed into natural log scale for better predictive accuracy. Results and discussion. Classified images and classification accuracy. LULC maps of 2000, 2010 and 2020 are given below. The kappa coefficients for 2000, 2010 and 2020 are 0.91, 0.90 and 0.92 respectively, indicating a good classification performance with all values above 0.90. And these classified images which are having a good kappa coefficient value will be used further for this analysis. Submodel parameterization, transition potential, change prediction, validation, and future LULC change prediction. A transition map has been created using LULC maps from 2000 and 2010. Over this period, total 29 transitions were identified. To run transition submodels, MLP neural network technique was adopted. Simulation of LULCC and urban sprawl prediction. These two images on the upper right side of the slide shows the predicted map of 2020 in left and 2020 30 in right. For the validation purpose of this predictive image of 2030, ROC and AOC curves and their values were identified, were created. The ROC curve is given below in the lower right side of the slide. The ROC values recorded for agricultural land, vegetative cover, built up water body, scrubland, and zotic land are 0.62, 0.65, 0.91, 0.71, 0.79, and 0.81 respectively. As you can see, the ROC value for built up is 0.91, which is very high. And this transition models and these classified images were can be successfully used for the predictive measures of, belonging to urban sprawl. Result and discussions are continued in this slide. In 2000, the expansion of built-up class was very less as compared to the other LULC classes. It was just 5% of the total area. Scrub land was the dominant LULC class in 2000, followed by agricultural land. In 2010, built-up class experienced a big change in areal extent and jumped to 20.53% of the total study area. Scrub land remained the dominant class. In 2020, the area in 2020, area of built up again increased to 29.15% of the total study area. The agricultural area decreased significantly from 34,931.70 hectare in 2000 to 27,128.07 hectare in 2010, but then increased to 31,374.36 hectare by 2020. This fluctuation might be due to urban expansion and conversion of agricultural lands to other uses, followed by efforts to reclaim or expand agricultural activities. The LULC classes has been changed significantly in the projected map of 2030. In the 2030 predicted map, the built-up category has become the dominant LULC class with an area of 50,321.07 hectare. These tremendous changes in built-up classes indicate a significant transformation of the landscape in the study area over the coming years. It is apparent from the projected built-up map of 2020 and 30 that there is a gradual and continuous increase in the built-up area. This increase in the built-up area will expand the aerial extent of Lucknow city towards outer sites. The map of 2030 clearly explained the sprawling character of built-up class. Conclusion. The accuracy of simulation model results depends on many factors. One key factor is the quality of input data, especially multi-scale data from various satellite images at different resolution. Using drivers data can introduce errors and uncertainty. Properly preparing this data, including correct classification of satellite images, is challenging but crucial. Mixed pixels can lower classification accuracy, and the choice of a classification algorithm is important. Every simulation model has internal limitations that affect accuracy. For simulating urban growth, all relevant factors, economic, social, ecological, etc., must be considered. Thank you very much.